Now we will see solved problem number 2 in subnetting. We will start the session with the outcomes. Upon the completion of the session, the learner will be able to. Outcome number 1, we will subnet the given network based on host requirements. Outcome number 2, we will find the number of networks or the number of subnets. And outcome number 3, we will find the number of hosts per network or per subnet. Let's revisit what are the 5 steps in subnetting. These are the 5 steps. I request you to pause this video for a while and go through these 5 steps. I will directly dive into the question now. The question is, subnet the IP address 196.10.20.0 into 52 hosts in each subnet. If you are directly watching problem number 2 without watching solved problem number 1, I request you to watch solved problem number 1 first for better understanding. So let's start with the step number 1. We know step number 1 is identify the class of the IP address and note the default subnet mask. In the question it is mentioned as 196. If the first octet in an IP address, if it is between 192 and 223, it is obviously class C. So here this is a class C IP address and hence the default subnet mask is 255.255.255.0. So step 1 is done. Step 2. We will convert the default subnet mask into binary. When we convert the default subnet mask into binary, we will be getting this as the result because 255 means all bits are 1 in the octet. So we have 3 255s. So we have all 1s in the first 3 octets. And the last octet is 0. So we are filling up with 0. So step number 2 is also done. We have converted the default subnet mask into binary. Now let's move on to step number 3. Here we need to note the number of hosts required per subnet and find the subnet generator and the octet position. We know the number of hosts required per subnet is given in the question, which is 52 hosts required. So the number of hosts required per subnet is 52. In order to find the subnet generator and the octet position, we need to first convert the decimal number 52 into its binary equivalent. When we convert that into binary equivalent, we'll be getting 110100. Let's verify that. Let's bring in a calculator. I'm choosing the programmer calculator and let me type 52. When we type 52, it is the decimal number. The decimal number 52, its equivalent is in binary, it is 00110100. As I already mentioned in the previous lecture that we should not take this leading zeros. That is the prefix 0 should be omitted. So we will be getting 110100. Here it is 110100. And that's it. So we got the binary equivalent for the number 52. So how many bits are required in binary in order to get this number 52? We need 6 bits compulsorily. So without 6 bits in binary, we can't get the number 52. So this 6 bits plays a vital role. Now what we are going to do in order to generate the subnet generator and the octet position? First we need to take this subnet mask, right? It's a class C subnet mask, right? So I'm just bringing in this subnet mask here. And how many zeros we are going to reserve? 6 zeros. 6 zeros means we need to start from the right. So it's obviously 8 bits are there in the 4th octet. Anyway, we are going to reserve only 6 zeros. We need to reserve 6 zeros from the right. Then after reserving the 6 zeros, we need to fill all 1s in the remaining places. So all the remaining places are filled with 1. So as we already know in a subnet mask, if it is a valid subnet mask, it should be continuous 1s. If a 0 is started, then the 0 should proceed till the last. So this is a valid subnet mask. Now, how to find the subnet generator? We need to find the decimal place of the first one we are encountering when we move from right to left. So this is 2 power 0, 1. This is 2 power 1 is 2. This is 2 power 2, 4. This is 2 power 3, 8. This is 2 power 4, 16. This is 2 power 5, 32. And this is 2 power 6, which is 64. So the decimal place for the first one which is encountering when we move from right to left. So the subnet generator is 64. And where this subnet generator is occurring? Is it in the first octet? No. Is it in the second octet? No. Is it in the third octet? Obviously no. And it is in the 4th octet. So octet position is 4. Step number 3 is also over. Now let's move on to step number 4. The step number 4 is generate the new subnet mask. Already we have generated this new subnet mask. So what if all bits are 1 in an octet? It's obviously 255. So this is 255, this is 255, this is again 255, and this is 128 because this place is 128 and this place is 64. 128 plus 64 is 192. So the new subnet mask is 255.255.255.192. Or it can also be represented in a slash notation. How many ones are there in the new subnet mask? 8 ones here, 8 ones here and 8 ones here. So a total of 24 ones in the first 3 octets. 25, 26. So there are 26 ones. So we can also represent this subnet mask as /26. And that's it. We are done with step number 4 as well. Let's now see step number 5, where we are going to generate the network ranges, which is also called as the subnets. So we are going to generate the subnetworks or the network ranges. The IP address which is given in the question is 196.10.20.0. And we know in which octet position the subnet generator should be applied. It is applied on the 4th octet. So this is octet number 1, octet 2, octet 3 and this is octet 4. So the first subnet will start with 0 and then add the subnet generator to the 4th octet. So we'll be getting 196.10.20.64. So we got the first IP address of the second subnet. We will again add the 64 to the 4th octet of the second subnetwork. So when we add the subnet generator to this, we will be getting 128. So with this, when we add the subnet generator, we will be getting 192. Okay. So we have generated 4 subnetworks. Later I will tell you why we are generating only 4 subnetworks. So for this IP address which is given in the question, we are able to generate only 4 subnetworks. If the second subnet is starting with 196.10.20.64, and what about the previous network? So the previous network ends with 63, right? So the first subnet is 196.10.20.0 to 196.10.20.63. And what about the last IP address of the second subnet? Since the third subnetwork is starting with 128, the previous subnet will be ending with 127. Since the fourth subnetwork is starting with 192, the third subnet ends with 191. And that's it, we have generated the network ranges. If it is a class C subnet mask, it is 255.255.255.0. All of these IP addresses will be belonging to a single network because it will be checking only the first 3 octets. If the first 3 octets matches in an IP address, then obviously they are belonging to a same network. In this case, it will check 196.10.20. Since all IP addresses are starting with 196.10.20, with this subnet mask, they are belonging to the same network. But with this subnet mask, they are not actually belonging to the same network because we have generated a classless subnet mask. But coming to the topic, I already mentioned you a classful world wastes IP addresses. Suppose if we go for classful world, in this case we'll be having a maximum of 256 IP addresses possible per network. And obviously we are going to use only 254 because the first IP address, which is 196.10.20.0, is the network address and 196.10.20.255 is the broadcast address. And we have a maximum of 254 usable hosts or usable IP addresses. But if we go for this subnet mask, it's a classless world. We have 4 subnetworks and in each subnet we have a maximum of 64 IP addresses. For our requirement in this example, we need 52 hosts per subnetwork, right? But if we go for classful world, we'll be getting 254 usable IP addresses, but our requirement is just 52. So we are going to waste 202 IP addresses. But if we go for this classless addressing using subnetting, then we are getting 64 IP addresses per subnetwork and our requirement is 52. And obviously we are going to waste only 12 IP addresses. Not even 12. The first address and the last address are always reserved, right? And that's why in one of the previous lectures in the classless addressing I mentioned, it doesn't mean classless world will not waste IP addresses, but it will waste IP addresses, but this wastage will be minimal when compared to the classful addressing. So we have generated the network ranges and we have generated the new subnet mask. So with this subnet mask, 196.10.20.0 to 20.63 will be in one network. Say 20.64 to 20.127 will be in the other network, similarly in the other cases as well. So this can be applied to one local area network. A total of 4 local area networks are possible, and per local area network we can have a maximum of 64 IP addresses, but 62 IP addresses are usable. 2 IP addresses are not used because the first IP address of every subnet is the network address and the last IP address of every subnet is the broadcast address. For example, if we take the third subnet, which is this, what is the network address? It is 196.10.20.128. And what is the broadcast address of the third subnet? It is 196.10.20.191. That's it, guys. I hope now you know how to subnet the given network based on the host requirements. We found the number of networks or number of subnetworks we get, and we also found the number of hosts per subnetwork. I hope you guys enjoyed this lecture, and thank you for watching.